Hello, I will do some measurements here on this Torqeedo Travel battery. This charging port here, characteristics of that port. So I have bought this cable that is better than I expected. It seems to be a very good quality connector here. So I'll connect that one here. And according to the manual, it should be between 9.5 voltage and 50 voltage, and we need to be able to supply 4 amps. So here I have prepared a power supply up to 30 voltage, and I will start with 9.5 and then increase the voltage, and I will measure the current with this one and the voltage with this one. So let's see. Now I start with 9.5 voltage, and that don't give any current at all. So let's write down that 0 amps, and I increase to 10. It seems still nothing happens. Let's increase some more. Now I have 10.5 and things start to happen. So let's see, I write the voltage here, 10.4, and current 0.78. And by the way, the battery now is 78%. And now I will increase the voltage to 11. Now it seems it really starts. So at 11 voltage we have 3.73 amps. And the exact numbers, let's see, 10.5 actually voltage, and current 3.73. So the power is about 40 watts, and it will take about 1 day to fully charge an empty battery, about 25 hours. And let's go up to 12 voltage here. So now I have adjusted to 12 and I get 11.5. 73, about the same. Step up. Now I have 12.5, and the current is about the same, 3.73. Let's step up. 13.5, and the current is very constant, 3.73. So now we are down to 19 hours for a full charge at 13.5. .5, same current. And now the fan started in the power supply. 15.5. The current is very stable. Now we have 20 voltage on the supply, and that gives me 19.5 here. And current is very stable. And this is 73 watt, and it takes 13 hours to fully charge the battery. Now it's 20.5, and exactly the same current. And now it turns out to be at this about 22 voltage. It takes exactly 12 hours to fully charge the battery. Let's see. it 23, that gives 22.5. And now it's the set value is 24 and we get 23.5, and the current is the same, 3.73, and that's 88 watts and 11 hours. Now it's 25 voltage and we get 24.5, and the same current. The power is 90 watt and 10.6 hours to fully charge the battery. I think the supply unit I got with the motor is about 24 voltage. So this is, I think, like the Torqeedo power supply, that you get 90 watts and about 10-11 hours for a full charge. So let's continue here. And now we have got 1% in the battery, from 78 to 79. Now we have 26.5 voltage and the same current, 3.7, and then it will be about 10 hours to a full charge. And now we're 27.5 voltage and the same current, 3.73. We have passed 100 watts, and that gives 9.4 hours to fully charge the empty battery. Very approximative. Now it seems the current have decreased very little, but from earlier on it was constant 3.73, but now it's down to 3.71. So almost the same, but something have happened, start to happen. Now the set value is 30 and we get 29.5, and now the current is a bit lower, 3.68, 30.5. 9.5. 3.65. So now at about 30 voltage we get the current 3.65, 111 watt and 8.7 hours for a full charge. And now this power supply cannot supply more. We are at the top 31 voltage. So now I plan to connect this Victron charger that with the latest software I have connect with this Bluetooth app and change to power supply mode, so it will act as a power supply. So now I have to do some change in the setup here. Now I will connect this Victron power supply. So now I happen to have 19 voltage here. So I will go back to about 30. So now we are back to 27 and the current we had before. So I have to increase a bit here. Yes, so now we have this Victron charger in series with this laboratory power supply, and now we get 31.5. Off here is power meter. Let's see, now we are back 31.6 and 3.58 amps. 3.58. So now we have 113 watts and about 8.5 hours. We continue here. 22.6, 3.51, 33.6, 3.42. So it seems the current is decreasing for every increasing voltage here. So the power is about the same now. It seems it has reached a limit of about 115 watts and 8.4 hours to do a fully charge. But we continue to increase the voltage. Yes, exactly the same power now 114.9, 8.4 hours. Very constant power. Now at about 38 voltage, the current is exactly 3 amps and the power is 115, 8.4 hours. Now the current is below 3 amps, just below 2.97. And the power still constant. Now we are up to 40 voltage, 40.6, and current is 2.8. And power is still 115 watts, 8.4 hours. Now it's 44 voltage, 2.6 amps, and still 115 watts, 8.4 hours. Now we have 82% in the battery. Now I think we are about at the limit here again. So the highest voltage we can get in this setup is 45.3 voltage, and that gives a current of 2.54 amps, and the power is constant 115, and that gives 8.4 hours. So this port supports 5 more voltage up to 50 voltage, but it seems to be no meaning to continue here since the power is very constant. So I will just give a figure, a graph here on the result. title is a bit bad here, but here we can see the current. We had some problem here at very low voltage to get it started, but when it gets started about 10.5 voltage, the current is very stable up until about 27.8, and then the current starts to decrease, and up here at 45 voltage we have 2.5 amps. And if we instead look on the power, don't care about the title here, it's more than we have in the diagram. You can see here that the power increases when you increase the voltage up to about 33 voltage. So it seems if you want to charge as fast as possible, you can increase the voltage up to 33 voltage, but above that level it seems meaningless. And let's see, I will do a diagram with the hours. Here, just short. Just the calculation I did. I have voltage here, current, and I get the power. Just with multiply. And up here I have a battery capacitor, and I just assume some number here that 95% goes into the battery. And here I calculated from this 916 watt hour and calculated the number of hours. So that is a very high number. Maybe we can remove that, because here it have not really started. So let's add a diagram for this. Yes, maybe this result is, let's see. Maybe this diagram is the most interesting. That if you have 12 voltage from a car or a boat or something, it takes about 20 hours to charge the battery. And if you go to, let's say, 24 voltage, it takes about 10 hours. And then you can increase the voltage a bit more to about 30 voltage, and then you are down to 9 hours, and that seems to be as fast as it can go. Yes, I think that's about it for these measurements. I had a problem to find this information on internet before I bought this Torqeedo Travel motors. I hope this can help someone that wants to optimize the charging voltage. Thank you.